We are going to be looking at section 8.2 today. I've got a few examples that I'd like to work with you, so here we go. So last time we were talking about sequences, we were looking at lists of numbers, and these lists of numbers really were kind of falling into a couple of different categories. One category was called an arithmetic sequence, and an arithmetic sequence is really defined, so arithmetic, sort of a funny math word, but an arithmetic sequence is really defined where there is a common difference, a common value that you are adding to the number from term to term. So a pretty typical question is for you to determine whether a sequence is arithmetic or not. And so in this first example, it says exactly that. It says determine or tell whether each sequence is arithmetic. So let's go about doing this. So before we begin, let's call each of these numbers what they are in their sequence. So the first term, the second term, the third term, the fourth term, and the fifth term. So they've listed out 5 terms here. And let's find the difference in between each of these. So if I find the difference between the second term and the first term, I'm going to say -2 minus a -9. Now obviously -2 minus a -9 is just 7. And let's see if that number 7 is consistent as we do look at each consecutive set of numbers. So the third term in our sequence, if we subtract the second term from that, that would be equivalent to saying 5 minus a -2. And well, what do you know? That is also 7. So we have 7 consistently showing up. So the difference from term to term seems to be 7, but we do need to check and make sure that that holds. So is the fourth term minus the third term going to hold? Well, that's 12 minus 5. Yes, that's also 7. And is the fifth term minus the fourth term also going to hold? Well, that's 19 minus 12. Well, yes, that is 7. So yes, it is an arithmetic sequence. So I would say that this is a pretty quick way to determine if something is arithmetic, but you do have to find that consistent difference each time. Without verifying that, you don't necessarily know whether it's arithmetic or not. So let's take a look at this next example then. So example B is asking us the same thing. Let's quickly go through this. What's 15 minus 23? Well, that is a -8. And just because it's negative doesn't mean that it can't be arithmetic, but we do need to check and make sure that that holds each and every time. So 9 minus 15 obviously is a -6. Right away, this is enough information for us to say it's not an arithmetic sequence. And the reason being is that these numbers are obviously not the same thing. -8 and -6 are not the same thing, which is why it's not an arithmetic sequence. Okay, so moving on. And this is how the book presents it, and it's sort of a pretty similar work. See that they're taking the second term and they're subtracting the first term from it, and they're getting a value of 7 when they do that. And they verify that as they go. They're taking the third term and subtracting the second term from it, and they're still maintaining that it's a 7. So this is how the book would establish both of those answers. Okay, so let's see if we can take a look at a couple of problems here. It says tell whether each sequence is arithmetic, explain your reasoning. So for me, this would be a great time for you to press pause if you want. Press pause and see if you can tell whether these are or not. I'm going to continue to work them. So if you don't want to see my work, go ahead and press pause and see if you can figure this out. So 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is 3. Yes, arithmetic. The common difference is 3. All right, so question number 2, 9 minus 15 is -6. 3 minus 9 is -6. -3 minus 3 is -6. -9 minus a -3 is still a -6. So it's an arithmetic sequence. With a common difference. Common difference of -6. This last one then, problem number 3. So 4 minus 8 is a -4. 2 minus 4 is a -2. So it's not an arithmetic sequence. And the reason being is we do not have a common difference here. The differences jump from -4 to -2, so it's not arithmetic. Okay, all right, let's take a look then and see if we can do a different example. And here you can see the answers, sorry, from above. Arithmetic, each difference is 3. Arithmetic, each difference is -6. And of course, they say it's not arithmetic because the differences are not constant. Okay, let's take a look at a different example now. So here we're saying they want us to write a rule for the nth term. Now, writing a rule for the nth term is sort of like generating a formula. And so what we're trying to do is we're trying to figure out what a formula would be. And so the first thing I'm going to tell you is that we do have sort of a common template to follow. A general rule will always look like this for arithmetic sequences. To find the nth term, we're going to say a sub n, and that's going to be equal to the first term in our list plus n minus 1 times that common difference. So this is what I would call our general rule. And this would be definitely a formula that you want to write down because this is the formula that we will be manipulating as we look at each of these problems. So in this problem, they've asked us specifically to write the nth term, and then they want us to find the 15th term. So we're going to do that. I would always advise you to start with the general rule, and then the next thing I would ask you to do is to write out some information. So here's the nth term. The nth term is found by taking the first term plus n minus 1 times d. Now I'm going to go ahead and highlight we do need to find a number and put it in this spot, and we do need to find a number and put it in this spot. So what are those two things? Well, keep in mind that a sub 1 is the first term in our sequence. So for this particular problem, the first term in our sequence is 3. So the first term is just 3. Now what is d? D is that common difference. So if we're going to find the common difference, then we have to go through and make sure that we're finding the subtraction. So how would we find that common difference? We would say 8 minus 3 is 5. We would say 13 minus 8 is 5. And we would say 18 minus 13 is 5. So it appears to me that because this number 5 is consistently used, that is our common difference. That is that value. So the good news is we now can go back to this formula and we can erase d, and we can put 5 in that position. And we can erase the first term, and we can put 3 in that position. Now, most people would say, let's just box this equation up and say that's my answer. It can be simplified a little bit, so let's go ahead and do that. So a sub n is equal to 3 plus, I'm going to go ahead and distribute this 5. So 5 times n minus 5, and then I'm going to clean this up a little bit more. The nth term is found by saying 5n minus 2. That's the nth term. So we have done the first thing in our directions is we found the nth term for our sequence. Now the second thing that we haven't yet done is we need to find the 15th term in that list, and we could do that really slowly by adding 5 each time, or we can now just go straight to our formula. So if we're looking for the 15th term, then we're going to replace n. We're going to replace this variable n with 15. So let's go ahead and do that. So the 15th term is found by taking 5 times 15 and then subtracting 2. So the 15th term is found by taking 75 minus 2. So the 15th term then must be this number 73. That is the second thing they asked us to do, which is to find the 15th term. And that's what they asked for up here, the 15th term. Okay, now we're going to do this again, but we're going to do this for problem B, or example B. So it looks like they're giving us another list. But before we start, let's start by writing out the nth term. The nth term is found by taking the first term plus n minus 1 times d. And keep in mind that's sort of our generalized formula. And we're trying to find a number for both the first term and for that common difference. Now, the first term, it looks like, is 55, and we can see that because the first term is 55 when we look at our list of numbers. Now our common difference, well, that's a little bit harder to find, so we have to do some arithmetic. So what is 47 minus 55? Well, that is negative 8. What is 39 minus 47? Well, that is, again, negative 8. What is 31 minus 39? Again, negative 8. Looks like negative 8 is that common difference. So let's write out our formula now. The nth term is found by taking 55 plus n minus 1 times negative 8. Now, as we said earlier, we could just kind of circle that and call it a day, but we do need to clean this up. We need to distribute this out. So the nth term is found by taking 55 minus 8n, because we're distributing here, plus an 8, which means that the nth term is negative 8, let's see, plus 63. That is our nth term. So that's the first thing they asked us for. The second thing that they asked us for, again, I'm going to come up here and kind of point at this. The second thing they asked us for is to find the 15th term. So let's use this formula. So again, we're going to replace n here with 15, and that means we have to replace n here with 15. So let's do that. Negative 8 times 15 plus 63. So that means that the 15th term is a negative 120 plus 63, and of course negative 120 plus 63 is going to give me a negative 57. So that's the 15th term. That's the second piece of information that they wanted to give us. All right, so when we look back on these problems, they'll typically ask us to do two things. They will ask us to find a nth term, and they will also ask us to find a certain number within that term. And I've done both of those things here. I found the formula, but I also found a number within using that formula. Now, let me give you a few problems here, and actually before I do that, let me show you how the text would write this up here, both the solutions here. You can see they're working through it in the exact same way that I am. They're finding the nth term, and they're writing out the formula. So again, they're kind of always starting with this formula. Without that formula, it's going to get pretty hard to do. But the very first thing that they do is they substituted in the number 3 for the first term, and then they substituted in 5 for that common difference, and you can see that they worked that out. Okay, so let's get down and give you a couple problems to try. So they're saying here, write a rule for the nth term. They're giving you some numbers here, and then they say find the value of a sub 15. So again, if you're not quite ready to try this, go ahead and watch the video. If you want to maybe try this on your own, press pause, but let's start. So we're going to write out the nth term. A sub n is equal to a sub 1 plus n minus 1 times d. And then I'm going to rewrite it now, and I'm going to say the first term is obviously 7 plus n minus 1 times, and now I need to figure out what d is. 11 minus 7 is 4, 15 minus 11 is 4, 19 minus 15 is 4. Looks like the common difference is, of course, 4. And I'm going to distribute and clean this up a little bit. So 4n minus 4, 7 plus 4n minus 4. And then one last time, I'm going to write this out, 4n plus 3. That is the nth term. So I've done this part of the directions. The second part I need to do, the second thing that they're asking me to do, is I need to find the 15th term. So here I go. A sub 15 is equal to 4 times 15 plus 3. A sub 15 is equal to 60 plus 3. The 15th term on this problem is, of course, 63. Okay. Now, I hope that helps. I hope that kind of helps you to understand how to write an nth term or a formula for the nth term of an arithmetic sequence and how to use that formula. And let's see. Yeah, we got it right. That's good for us. The second thing we're going to try and do here is we're going to try and do a similar thing. We're going to still try and write a rule, but this time we're going to write a rule where we're given different information. So in this particular problem, we're writing a rule, but we're not writing a rule with a list of numbers. We're writing a rule where they gave us some very specific information. And so notice what they're giving us. They're giving us the 19th term in this sequence is negative 45, and they're also telling us the common difference is negative 3. So they are giving us some information, but they're not giving us all of that same information that they gave us before. Now, what are they asking us to do? They are asking us to write a rule for the nth term. So we're gonna start the way that we started in the past. We're gonna write out the formula. The nth term is found by taking the first term plus n minus 1 times d. Now, good news is, well, we know what the value of d is. They gave it to us earlier. The value of d is negative 3, so we know what this number is. We know that d can be replaced, and we can just drop in the number negative 3. What we don't know what the first term is. So this is where it's going to be a little bit challenging, but in order for us to solve this, we're going to take this information and we're going to go in a little bit of a different direction. So let's take that information and let's drop it in. Let's use it. So a sub 19 is equal to a sub 1 plus 19 minus 1 times negative 3. Now let's look at this just real quick. Notice that we're taking n and we're replacing it with 19, but we are being consistent because over here we took n and we replaced it with 19. Now my question is, do we know what a sub 19 is? Well, yeah, we do. It's right here. A sub 19 is this number, negative 45. So I can rewrite this again and say negative 45 is equal to a sub 1 plus 19 minus 1 times a negative 3. Well, what do you know? Good news, we only have one variable. So here we go. So negative 45 is equal to a sub 1 plus 18 times a negative 3. And of course, 18 times a negative 3 is going to give me, what is that, negative 30, negative 54. So I've got a sub 1 minus 54 is equal to negative 45. And solving that using some algebra is going to allow for me to say that 9, ooh, that's a bad 9. People are going to confuse that, I think. We're looking at add 54, 9 is equal to a sub 1. Now, after all that work, sometimes we get a little bit tired and we forget what it is that we're trying to do. Keep in mind, we are trying to write a rule for the nth term. So, the nth term is found by taking a sub 1, well, a sub 1 we know, plus n minus 1 times d, which we also know. So a sub n is equal to 9 plus n minus 1 times negative 3, and we're going to have to do some simplifying here. So 9 minus 3n plus 3, so the nth term is found by saying negative 3n plus 12. That is the nth term. Now, where do we go from here? They then also say, so second thing they asked us to do, then graph the first 6 terms of the sequence. Graph them. Well, what would the first 6 terms of the sequence be? Well, the first term, of course, would be negative 3 times 1 plus 12, which is, of course, 9. So a sub 1 is equal to 9. What would that look like as a graph? Well, you would graph the ordered pair 1, 9. What would a sub 2 look like? That would be negative 3 times 2 plus 12, which is, of course, 6. So what would that look like as an ordered pair? Well, let's first just say the second term is 6. So what does that look like as an ordered pair? It would look like 2, 6. So we can create a list of these ordered pairs, and then we can graph them. And what you'll see is it'll end up creating a bunch of dots on a grid that look like a line. But let's assume that we can do that, and let's take a look at the answer down below here. So you can see they're working through the same thing that we did earlier. The one thing I do want to point out is they made a table of values. So they found that the first term was in fact 9 and the second term was in fact 6. And because we can see that the common difference is negative 3, we can just kind of use some arithmetic to work forward. So they're generating this table of values. But the unique thing about this is that we're looking at dots on a graph. We are not looking at a solid line. So when we're graphing a sequence, it will always be a discrete graph, discrete sort of a fancy math word, of individual points. It is not connected points. Okay, so let's move on and let's take a look at writing the rule given two different terms. This is where we're going to have to still write an nth term. So we're going to start a sub n is equal to a sub 1 plus n minus 1 times d. But they're asking us to write a rule for the nth term. So again, we're still writing a rule. That's why we started with that formula. But they're giving us two pieces of information. So now what I'm going to do is I'm going to work in color here. I'm going to do everything sort of in this green relating to that order, that piece of information, and I'm going to work in a blue for everything that's sort of using that information. And so I'm going to take this formula and I'm going to work in sort of two different ways. So let's start with a green if we could. So a sub n, let's say a sub 7 is equal to a sub 1, which we don't know, plus 7, which is our value of n, minus 1, times d, which we don't know. Now, a sub 7, keep in mind, a sub 7, we said this number, a sub 7, we said is equal to 17. So we can replace that now. 17 is equal to a sub 1 plus 6d. Now, this is an equation. Let's put a box around it. It has two variables. Let's work through and see if we can find a second equation now. So a sub 26 is equal to a sub 1 plus 26 minus 1 times d. But again, keep in mind that a sub 26, this term here, was given to us up here. A sub 26 is the number 93. So 93 is equal to a sub 1 plus 25d. A second equation now with two variables. Now we look at these two equations and we sort of stare at them for a little while, and all of a sudden we realize, oh wait, you know what? I have two equations, I have two variables. We learned how to solve these types of problems in an algebra class. So let's take these two equations, let's use the elimination technique. I've got 93 equals a sub 1 plus 25d. I've got 17 equals a sub 1 plus a 6d. And let's subtract these two equations from one another to get rid of the a sub 1. So let's do that, but let's keep in mind 93 minus 17 is going to go on the left. So 93 minus 17 is the value of 76. A sub 1, of course, as we said earlier, cancels out. And 25d minus 6d is going to be equal to a 19d. And we're going to solve for this by dividing both sides by 19. It looks like d is 4. So we've got one of our two variables solved for. Let's take this and let's plug it into this equation. 17 equals a sub 1 plus 6d. Let's plug it in for d and solve for a sub 1. So 17 is equal to a sub 1 plus 6 times 4. 17 is equal to a sub 1 plus 24. So it looks like the first term is going to be a negative 7. Now we've got these two variables. What were we even asked to do at the very beginning of this? We were asked to, again, remember what it is we were doing. We were asked to write a rule for the nth term. So let's do that. So again, the formula would be a sub n is equal to negative 7 plus n minus 1 times 4. But we're going to distribute that, clean it up a little bit. So a sub n is equal to negative 7 plus 4n minus 4. A sub n is equal to 4n plus 3. That is our nth term. And if we scroll down here, we can kind of see they're doing the same thinking as we just did. Oh, sorry, I made a mistake. Good thing I caught it. So we distributed a 4. It should be minus 4, but I've got a negative 4 and a negative 7, so that should have given me a minus 11 here. So there's our answer. And it's the same thing that they gave us here. Okay. Now, I'm going to scroll down here and I'm going to say that we have two problems that look very, very similar. Again, now would be a great time to press pause. But if you want to try this on your own, please press pause. If you want to just kind of continue to hear me talk about some of these, let's go ahead and keep moving. So our job is to write a rule for the nth term, and then, so second thing they're asking us to do, then they want us to graph the first 6 terms. So let's start with writing a rule. Let's start with this first thing. So let's write our general formula. A sub n is equal to a sub 1 plus n minus 1 times d. They're giving us d. They're giving us d here, which is good. They're giving us this consistent value of d, so we know what d is. Let's replace it. So a sub n is equal to a sub 1 plus n minus 1 times 7. But what we need to do is we now need to take advantage of the 11th term being 50. So let's do that. So a sub 11 is equal to a sub 1 plus 11 minus 1 times 7. But again, a sub 11, they previously told us, is 50. So 50 is equal to a sub 1 plus 10 times 7, which of course is 50 is equal to a sub 1 plus 70. Subtract 70 from both sides. Negative 20 is equal to the first term. We do all that math, and sometimes we forget what it is they asked us to do. They asked us to write a formula. That formula is going to start off by looking as a sub n is equal to negative 20 plus n minus 1 times 7. And we are going to clean this up. So a sub n is equal to negative 20 plus 7n minus 7. So our final formula is a sub n is equal to 7n minus 27. That is our formula. Whoops, got a little too close there. That is our formula. What would that look like as a graph? Well, again, if we were going to graph this, we draw an x and a y axis. To me, it would look like we would have our tick marks go all the way down. Sorry, actually I made a mistake here. We would have to graph this, and our first answer, our first term, when n is 1, would be down at negative 20. So when n is 1, we'd have that number at negative 20, and it's going to go up 7 each time. So negative 13 is where we'd be for the second term. And for the third term, we'd be at negative 6. And for the fourth term, well, for the fourth term, I think we'd be at, well, 4 times 7 is 28. 28 minus 27 is a 1. So we'd actually be at 1. So I'm going to have to erase this little 4 and put it down below, because our fourth term would be right there, and so on and so forth. So that's kind of what the graph would look like. All right, so I hope that helped. I hope you learned a little bit about writing the nth term for an arithmetic sequence. And I'll go ahead and show you the answer here. That's what the answer they gave for us for that problem. And always, if you have questions, please ask.